Hello, this is Professor Baswite. Today we'll actually get started with exponential and logarithmic functions. All right. You should watch the inverse function video before this for this all to make sense, okay? All right, let's talk about it. An exponential function looks like this, and I'm going to kind of like make a little table. A to the x. A is just any number. Let's look at it. Let's say I'm doing f of x equals 2 to the x power. What you're doing is x and 2 to the x. You're taking an x, which is 0, let's say. X to the 0th power is going to be 1. So anything to the 0th power is 1 except 0, remember? So all my exponential functions are going to go through 0, 1. So that is one important thing. But what will happen when x is 1? 2 to the 1, which is 2. So when x is 1, it's going to be 2. Do you see that? When x is 2, it's going to be to the 2nd power, which is 4. When it's 2, it is 1, 2, 3, 4. Watch. You see that? And when it is 3, 2 to the 3rd, which is 8. When it's 3, it's going to be 8. 1, 2, 3, 4, 5, 6, 7, 8. Like that. 1, 2, 3, 4, 5, 6, 7. Oops. I can't see my own handwriting. 1, 2, 4, 5, 6, 7, 8. Here you go. Okay? So you just plot these points and you get an exponential curve. So it looks like this one is the picture of 2 to the x. What will happen when you're in the negative? Let's try -1. Watch, 2 to the -1, which is 1/2. Oh, look what's happening. When it is -1, it is actually getting smaller. Do you see that? When you go more negative, it's actually getting even smaller. All right? So 1/2, 1/4, 1/8, and all that. So this thing is going to go down very close to a zero asymptote. That is very typical when I have a base. This is called a base. That's bigger than 1. Let's look at another one. Let's say instead of 2 to the x, I have x and 10 to the x. When x is 0, this is actually 0. 1. When x is 1, this is 10 to the 1. When it's 2, it's 10 to the 2nd. So it's going to get very, very big, very, very fast. Look, it's going to start with 1. It's going to get big very, very fast. Are you with me? What will happen in the negative side? This is going to be 10 to the -1, which is 1/10. See what happened? So it got small very, very fast as well. It's kind of like pivoted like that, like a door around 0, 1. So, watch. So when your base gets bigger, your exponential curve gets a little bit steeper, and this is the picture of 10 to the x versus picture of 2 to the x. So we analyzed the exponential functions. Also, let's look at the domain and range. Domain is the x values. Can I put in anything I want in there? Yes, you can. So the x values is going to go from -infinity to infinity. That's my domain. But what happens to the range? Those are the y values. Watch, this thing always stays above the x-axis. What does that mean? And it never hits 0. So my range is 0 to infinity, and that's my range. So when I have an exponential function with a base bigger than 1, it will go up very fast, and the base is bigger, it's going to even go faster, but it will never cross the x-axis. Very good. Now let's look at an exponential function, but this time a is something that is smaller. So let's look at, I don't know, like f of x equals 0.1 to the x power. So let's go do that. 0.1 to the 0th power, that's going to be 1. So that's, no matter what, that's the case. But at 0.1 to the 1th power, so in other words, at 1, it's going to be small. Does it make sense? Let's say someplace here. Okay, at 2, it's going to be 0.1 to the 2nd power, which is 0.01. Does it make sense? It's even smaller. Are you with me? Let's look on the negative side. Let's say -1. That's going to be 0.1 to the -1, which is 10. Oh, look at that. At 1, it is going to be 10. Very, very big. So look at this. If I have a 0.1 to the x, it's going to look like that. It's going to be pretty steep on the negative side, but it's going to be very close to the x-axis on the positive side. So let's look at something else. Let's look at f of x equals, let's say, 0.5 to the x. Let's go do that. 0.5 to the 0th power. When it's 0, this is going to be 1. That's given, so it's going to go like that. When it is 1, it's 0.5 to the 1st power, so it's going to be 0.5. So when it's that, it is kind of higher than 0.1. Do you see it at the same location? It will eventually go and approach the y-axis, x-axis, but it's going to do it a little bit slower. Do you see that? It's going to do a little slower. In other words, it's going to do this if I have a 0.5 to the x situation. What will happen on the negative side, -1? It's going to be 0.5 to the -1, which is, what does that mean? 1 over 0.5. What is 1 over 0.5? That's 2. -1, it's going to be 2. Do you see that? So it is going to go up, but it's not going to go up as fast as the blue one. So this is the picture of 0.2 to the x. Do you see it? So it also pivoted like that. So it's closer to the x-axis when your base gets bigger. So let's look at domain and range. Domain is you can plug in anything you want, it looks like. How about the range? It's going to stay on the positive side. Does it make sense? All right, here are our exponential functions. And what will happen is when your base is between 0 and 1, your exponential function is going to work like this. Now let's look at the logarithmic functions. Let's look at an a that is bigger than 1. Here's my exponential function. And now I will actually define this. A logarithmic function is the inverse of my exponential function. This is my f of x, which is a to the x. And this is my a inverse of x, which is going to be log base a of x. Does it make sense? And remember what we had said about inverse functions before. It's going to be mirror imaged with respect to y equals x. Now remember what it was. Now what are the domain and range of exponential functions? Domain is -infinity to infinity. Range is 0 to infinity, right? And I know that x and y are interchanged. Look at this one. The domain of the inverse is going to be positive side. And the range is going to go from all the way negative to positive. What does that tell you? You cannot take the logarithm of a negative number. And you cannot take logarithm of a 0. Okay? Very good. Actually, those logarithms are built into your calculator. When you push the logarithm, The one that's built on is base e, which is 2.7, and base 10, which is 10. Those are the most popular ones. To calculate logarithms of any other bases, you need to use change of base formula. But nevertheless, they will behave kind of similarly. Let's look at when a is between 0 and 1. Remember what your f of x looked like. Remember what it looked like? It was like that, and it was crossing at 1. This is the picture of f of x, and it's a to the x. Remember, I said the logarithm is inverse of your exponential function. Remember how it looks like. It's going to be mirror imaged. And what is going to happen? My horizontal asymptote is going to become vertical asymptote. And this piece is going to come down that way. Again, I cannot take logarithm of negative numbers, but it's going to behave a little differently. Remember how it was? So my previous logarithm was going this way, and this one is going that way. Okay, so remember that. You cannot take logarithms of negative numbers. All right, good. Okay, now what I'm going to look at certain popular logarithms. When I have a base 10, remember how I write the logarithm? Log base a of x. This is how you read it. Log base a of x. Okay? And what was a? A was either bigger than 1 or between 0 and 1. Now, if my base is 10, the log is not going to take that a. This is when a is 10. You don't have to put that 10 in there. You are going to put log. Okay, sometimes it's in capital letters in Europe, but it's log. Here's the picture of 10 to the x. Here's a picture of log of x, and they are mirror imaged along y equals x. Okay? So I know one popular logarithm. Now, that one, log, when you look at your calculator, it's going to show as log, and it is built into your calculator. You can push the button and push the number. It will take the log for you. All right. Here's another popular one. Base e. What the heck is e? E comes from the nature. A lot of people try to model behavior of nature, growth, and those kind of things, and they came up with this magic number. I want you to memorize at least maybe 2 digits. 2.718 or 3 digits, something like that. Either 2.7 or 2.718. Now, that is shown as e, and when you have a log base e of x, you use this notation ln of x. Okay, so that's also built into your calculator. So when you see ln of x, and that is your base e. Unfortunately, in some European countries, I also saw it that log in caps is the log base 10, and log not in caps is log base e. But I think everybody's switching now when they are using the ln instead of the lowercase log. You may see that, just don't be surprised. ln is log base e. What does it look like? It's going to be a little bit flatter. Here's your e to the x, and here's your ln of x. Here's 0, 1. Here's 1, 0. They are mirror image along y equals x. All right, very good. Now let's put it all together. E to the x versus 10 to the x. Let's do that. E to the x is going to be this one. E to the x. And when you mirror image that, so it is the one that's closer. This is ln of x. They are a couple. All right? Now let's do 10 to the x. That's going to be a lot steeper. 10 to the x, right? It goes fast, and that's going to be closer to that. So this is going to be 10, log base 10. And what will happen? Remember how this works? This is 10 to the x. It pivots. It's under. Okay, pivots. It's under. Do you see it? Here's my log and 10 to the x. Here's my ln and e to the x. All right. That's very good. Okay. Let's do some translations. Vertical translation, what does that mean? Let's take e to the x, and I know this is 0, 1. When I translate it at 3, that 1 is going to become 4. 1, 2, 3, 4. Do you see it? And this is going to go up. It's going to go up the same way. And this asymptote at 0, it's going to move to asymptote at 3. Does it make sense? So watch. This is e to the x. This is e to the x plus 3. Do you see that? That's called vertical translation. How do you do vertical translations in logarithms? ln of x. Go with the intercepts. Here's 0, 1. What will happen to that? I mean, this is 1, 0. What will happen to it? It's going to be 1. It was 0. Now it's 3. 1, 2, 3. Here we go. So this will move to that. It will still go like that. They're going to stay parallel, but the asymptote is going to stay at the vertical asymptote at 0. Vertical translation of ln. How about this one? Horizontal translation. How do you show that? You're going to go either subtract or add. When it's subtract, it moves right. When it's add, it moves left. Okay, e to the x. And the way you should do that, this is 0, 1, remember? It's going to move to the right 3 steps. 1, 2, 3. And this will become 0, 3. Okay? So I will move this to this, and it's going to stay horizontal asymptote, and it's moving. It's going to stay parallel. Horizontal translation. It moved to the right because of the negative. If it was positive, it will move to the left. So you don't have to have all these points plugged in to do those translations. Horizontal translation of ln. Let's look at it. Here's ln of x. Here is 1, 0. When you move it to the right, what will happen to that 1 will become 4. 1, 2, 3, 4. Okay? My vertical asymptote. Here is a drawback of a graphing calculator. What does that mean? It stops in there? No, that's not what it means. It means just the pixels are too big for it to display. So this is 4, 0. And what will happen to my vertical asymptote? It was at 0. Now it's going to go to 3. Actually, this thing is going to behave like this. Like this. Are you with me? Okay, very good. Reflections. What does that mean? Along the x-axis. Here's my e to the x. Reflection. That happens when you put a negative in front of your function, e to the x. And this is negative e to the x. Does it make sense? Reflection along the x-axis. How about reflection along the y-axis? Here we go. E to the x. Now instead of x, you're going to put a negative x. Negative e to the negative x. This is e to the x. This is e to the negative x. And that makes sense because when you put e to the negative x, it's 1 over e to the x, and 1 over e is less than 1. And that's an exponential that goes that way. All right, let's talk about stretching. ln of x. Here's my ln of x. All right. when you multiply 0 by 0, you're going to get 0. But when you multiply anything else by 5, this is going to be 5 times bigger. So do you see this? This is ln of x. And this is 5 times ln of x. But it did like stretch over like that vertically. Okay, let's put it all together. What's that mean? Let's take my e to the x. And let's do all this to it. What does that mean? Oh my God. All right. What this will do is it's going to move it to the left one point. So it's going to move like that. All right. Move to the left. And then negative 3 multiplied by 3, so it's going to even become more steeper, right? All right. And then what will happen is it will be mirror imaged along the x-axis, and here's the picture of it. Are you with me? So horizontal, steeper, reflected. So you can actually play with this and just play with your calculator, put in a bunch of different translations, and kind of take a guess and see how your guess ended up.